Hello guys, how are you doing? Today you are gonna to see spatial modeling and we'll see find the site for a new school. Basically not only for a new school, for a new hospital, for a new industrial site, for a new real estate or for a new landfill site and any site that you are gonna to model, you can use this model. For our exercise, we are going to see this exercise finding a site for a new school. Okay. Under this, we will see this important steps. First off, we have to create a new toolbox in our folder, and we can name it as Optimum Site Analysis tool, and then we will create a model, and then following that, we will specify the environment in the model and we will generate drive the data set and then reclassify it and then combining in with it overlay tool. And then finally we'll select the best site. So go to open your previous data. By the way, this is the continuation of the previous exercise. We have seen exercise 1 and 2. This is the easy data, and for our exercise and the simplicity, I make a video and here is it, right? So now the first step in this exercise is creating your new toolbox, right? Go to your folder and right click in folder and create toolbox for your model and rename it optimum site optimum site selection or analysis. Optimum site analysis. Okay. Next on that, create your model. Okay. New your model. This is your model. Here. This is model builder. Your model that you are gonna to find a new site for your new scope. Go to this tab, model tab. Here you do have this tab. Around 6 tabs are there. In order to need help, you can click this help and you can get very extensive and detailed and intensive help from this help tool. And go to this model tab and go to model property, right? And this model property, go to general and then here the name should be find what scope, and here level should be find location for scope. Location for what scope, and then here check this store related path name and apply and okay, right? And then go to and then go to the environment here. Ready? Here we have set this one and go to the environment and expand this extent and extend and this raster and cell size. Now we are going to set the extent and the cell size. When you select here, you can get this one in the value here. Extent should be same as elevation, right? This is very important, especially if you have area of interest. You can limit the analysis onto your area of interest, right? So the place where that you set your area of interest is here in the model environment setting, okay? And raster analysis setting, same as elevation. That means cell size setting. Okay, this matters in your analysis, right? Cell size and the resolution to have the inverse correlation, right? When the cell size is large, resolution is very small, right? And vice versa. So here you have 30 by 30 pixel size. That means 900 meter square size of a pixel. So we set our analysis on this pixel size. Very good. So, okay, and again, okay, here, and save your model. Now we set our model. Okay, the next step is driving dataset. For example, we can drive dataset from what? School. We can drive distance to school. From recreational site, we can drive distance to recreational site. And from the elevation, we can drive slope. So now drag your school and recreational site and elevation to your model. Drag like this and put here. The next step is go to Arc Toolbox and Spatial Analysis Toolbox and go to Surface Toolset and drag this slope tool to elevation and go to distance Spatial Analysis Toolbox, distance toolset, and drag this then distance to school and recreational site, and then use this connect tool to connect your model. Okay, to connect your model or to connect the data set with the tool, right? And click auto layout and full extent, okay? And click the select tool in order to make free your cursor. All right, now this is the first model. It looks like this one. But here, for example, this is elevation, okay? Renamed this one as slope out. Slope out. Okay. This one should be renamed as distance to recreational site. Distance to recreation sites. Recreation sites. Okay. And again, this one should be renamed as distance to school. Sorry, to schools. There are more than one school and schools. And then add to display, don't forget this one, to automatically to add your output to display, right? Add to display. And the next step is reclassifying it. Before that, let's run our model, right? Yeah, that is 10. We have, so you can see, we did it. This is distance to school, and this one is distance to recreational site, and this one is the slope. Okay. The next step is reclassifying dataset. We have to reclassify dataset. Why we have to reclassify dataset? Here we do have these ranges, right? Ranges of distance and the slope out. So how can we reclassify it? By giving a common measurement scale, because weighted overlay tool never combine factors in different state of form, like land use in land cover class, slope in degree, and distance in meter, right? It never combine this. Therefore, we have to convert this into a common measurement scale using what? Reclassification. Reclassification is a best tool in ArcGIS in order to give new value, in order to convert our value into new combinant value for analysis, right? So use reclassify tool, go to your toolbox, and I think spatial analysis tool, the toolbox, spatial analysis toolbox, and okay, all right, raster. It's not here, and okay. Reclassifying tool, find this reclassifying tool. Okay. Okay, so you can drag this reclassify tool from Spatial Analyst toolbox, reclass toolset, to your model. This for this one, and this one for this one. You should reclassify tool, reclassify tool in your model, and connect this by using this one, and like this, and like this. Okay. Now, okay. Now here elevation, right click and rename this one. Reclassed slope. Okay, reclassed slope. This one is should be renamed as reclassed distance to regression sites, and this one is distance to score. Reclassed distance to score. Scores. Okay, here's that one. Scores auto layout and full external. Okay, now here we have this reclassification. Now let us open the reclassification tool for slope. Open it. Okay, you see here slope out. Here we have default reclassification 9 classes, new values, but we need 1 to 10 classes, new classes, right? Because we are going to give a common measurement scale into our output from 1 to 10, right? So now this common measurement scale should be 1 to 10, and go to classify. Here classes, number of classes should be 10, and the method should be call interval, and then okay. Now we have from 1 to 10, right? But one thing here also, we have to do one thing, right? You see here, this is the alt value is the slope value, slope steepness from 0 to 7, and this one tells us the, especially the smaller the number of the value of slope tells us that is gentle and flat area, okay? And the larger the number of the slope in degree, this is in degree, tells us that is a steep slope. So you see, so we are going to give the scale from 1 to 10. The larger the number of scale means the area is suitable. For example, if you give 10 for your area, or for the factor, that means that is high suitable area, right? So we never give high value for steep slope, because steep slope is not suitable for school development or to build a school. So we have to reverse this, see, to give high value for the suitable slope side, like this, for gentle, flat, and moderate slope. We have to give high value, because the higher the scale is, the more the suitable the area, right? So reverse the value. Here we do have this method, reverse it. Yeah, now we give high value, high scale to the moderate or the flat or gentle slope, right? And we give small scale to the steep slope, right? Steep slope, because we never built our school on steep slope because of these different factors, the landform factors, right? So this is the method how to arrange our classification here. And then, okay, next that, let's come to regressional side and open here. Okay, sorry, open the tool. recreational site. Okay. You see, by default, recreational site classified into 9, but we need how many classes? 10 classes. Go to this classification, make this 10, and the method is the call interval. We have used, we have used that one, and now we have 10 classes or scales of measurement. These are the common measurement scale that we give for slope, and again for distance to recreational site, and again we'll give for distance to school. But here again, we have to do something. Look at this one. This is the old value tells us the distance of each sites of recreation, right? Distance of recreation. So this is the distance of recreation from 0 up to this one in meter. Okay, this is the largest distance. This one is the smallest distance. Okay, therefore the closer the new school to recreational site is, right, the best or the optimum the new site for school uh, development. So we have to give high value for the site which are close to the recreational site. Okay, so we have to reverse again this one, this value. You see, 10 for the area which is close to this the recreational site. That means we are gonna to build a new school to the close to the recreational site. And now we are, avoiding to build a school which is away from the recreational site, right? We give small value. And again, okay. Now let us come to this call. Again, by default, we have 9 classes. Now let's classify it into 10 classes and the call interval, and okay. Now let us see this one. This tells us the distance of the school. The distance of the school. This is close to the school. This is away from the existing school, right? So we need to build a new school which is away from the existing school, right? So we have to give high value for the high distance away from the existing school. It should be as it is, okay? And okay, and then add to display. Add to display and add to display. This means automatically the model display the data after computing it. Okay, now compute your model. Thank you. It is done. It is done, and save it. It is done. You can see here in your in your table of content. Here we have the common measurement scale. Our you see in the common measurement scale. Okay. The next step in our model is weighting and combining data set. Combining our data. So the weighting and combining in the suitability model. Here to combine, we have to have a percentage of influence. And by the way, the scale percentage of influence as such scale should be given based on review literature and expert judgment and experiment. The three things are a must, right? We never give a integer number or any scale without any justification. Okay, we have to have justification to give a scale, a common measurement scale. This is for our practice, right? If you have any project, if you will have, or if you have any project conducted in a given area or in your area of interest, you have to have these sources in order to give the scale, common measurement scale, as well as the percentage influence for your factors, right? So we can use the weighted overlay tool in Spatial uh, spatial analysis tools box overlay to save, weighted overlay, drag it to your model. Okay, now before any process in this weighted overlay tool, you can open it and set the scale measurement, right? Here it is. The default is evaluation scale. Default is 129 by 1. Now ours is what? 1 to 10 by what? By 1. Okay, apply. We set it. Okay, now let's add our reclassified data set. For example, the first one is what? Reclassed slope. Input field should be value and okay. You see here, reclass the slope. The field value here you do have 10 and the scale value here you do have 10. Okay, but still we have something to be done. We never built our school in steep slope area, very steep slope sites or locations of of our area of interest. So we have to restrict from 1 up to 4. We have to restrict, even we never compute this site. We never let our model to compute this site because it is very, very steep slope. So we restrict or make it out of any computation, restrict it. And next are the distance to recreational sites. Okay, be careful. Distance, reclassed distance to recreational site value should be, the input field should be value. And okay, you can collapse this one. Here we do have this, it is okay. All right, and then the next one, distance to school. Yeah, it's okay. And the last one is land use land cover class. Still never do anything on land use land cover class. Now input field should be not value, should not be value, should be land use land cover. Okay, and okay, now you see the field value is what? Field value is land use land cover classes. Here again, we have to give scale value for our land use land cover class. How can we give? Simply by guess? No. As I told you, when we give scale, we have to read literature and we have to consult expert and we have to have experimental ground. So based on the three important scientific ground, we can give scale. For our practice, we can give for this transitional land, it should be 5. And for water, can we build school on water? No, we have to restrict it. Barren land should be 10. On barren land, you need that land. Built up 3, right? And you have to somewhat restrict it, giving small scale. Agricultural land 9. That means we compensate. We will compensate the agricultural land compensation cost for the owner, right? And forest should be 4 because it needs ground work. Wetland never built. School never built on wetland, restricted. All right, now we have finished. But we left with one thing, percentage of influence. How can we give this percentage of influence? Again, we have to give percentage of influence by expert judgment and experimental value and literature review. We have to review intensive literature and then we get a knowledge how to give this percentage of influence of the factor. So now let us give for our practice for slope. Can give 13 here. You see this message that this means the sum of all this percentage influence should be 100, right? And then reclass distance to, you can hover your cursor to read the full name, Distance to recreational site, it should be 50%. That means this is the most important or influential factor for school site analysis, right? In this case, distance to school should be 25, half of that of recreation site. Land use and 12, this is the smallest one, okay? Now we have finished. And you can make it okay. You see, automatically it connect our model, connects all these factors. Okay. And output should be renamed as, you have to rename the output as optimum area. Let's say this optimum area. Optimum areas. Okay. Okay. And then add to display. Add to display. Add to display. And then run your model. Run your model. Yeah, it is done. Save it and you can see your model. You see here, this model from 10, from 0 to 9, 0, 4, 5, 6, 7, 8, 9, based on suitability, right? 0, it is not suitable, especially the steep slope area and the water body and the wetland area are restricted, so it is 0. So we never built this, or it is out of any suitable site competition. 8 and 9, suitable areas. 9 is the most suitable one. Okay. Now we are going to select optimal site, the most optimal site. The most optimal site of our study area. Which is the most optimal site? How can we select it? We can use contour. Contour. Okay, go to arc toolbox and spatial analysis toolbox and conditional tool set and drag your contour. Okay, open this contour. Open it. Our input should be input conditional raster should be optimum areas. Okay, optimum areas. And this expression should be value is equal to 9. That is optimal area. Value is equal to 9 for the expression. Input to raster, optimal areas again. This one. Input to raster, optimal areas. Okay. And output variable. Okay. Okay. So here the can make it okay now, and this one, this output should be renamed as output variable should be optimal. Most optimal areas. Okay, most optimal areas. Okay, auto layout, full extent. All right, this is done. And now run your model. Testing. Yeah, it is okay. You see here, 9, only 9. Okay. Auto display. Yeah. Only this 9 is suitable. Where is the 9? Okay, this. Okay. You can change this color into somewhat visible color. And you can see here. It is around here. That is the optimal area. Around here. Okay. Optimal areas. Okay, can pull extend, and you can see other parts. Here are also, you can see, you can investigate where are optimal areas. Okay. Okay, the largest one is around here. Okay, you can save it and then go to the next step is refining. We can refine this one, go to the Spatial Analysis Toolbox and Generalization Toolset. Spatial Analysis Toolbox, okay. There is Generalization Toolset and Majority Filter. This one is very important to avoid some small areas. For example, a pixel, a single pixel can't be a site for school construction or school development, right? So we have to avoid this very small and insignificant areas using the majority filter tool. So open this tool, and then our input is most optimal areas, and here should be 8 instead of 4 number of neighbors to use, and majority filter output variable should be filtered optimal site. This one should be renamed as filtered optimal site. Optimal site, filtered optimal site. Can add most, filter the most optimal site. Auto layout and full extent, and right click and add to display. Okay, and run your model. Yes, you see now, small, very small areas are excluded. See it here is pixel, single pixel, and the very small areas. Only large areas are included. Okay. And the next step is select the best site. Select the best site, okay? Select the best site. How can we select the best site? First of all, we have to convert this raster to polygon, okay? Go to conversion toolbox. It is a toolbox, it is here. And from raster toolset and raster to polygon, drag this one. Can convert this and open this tool, and our input should be filtered most sites. Value should be there, and input, okay, name of output should be most of the area. Okay, most of the area. This output should be most of the area. You can say this one, most of the area. Most, let's go, of area, this feature, right, or polygon. Auto layout and will extend most of the area and add to display. And run your model. Yes, it is done. Most of the areas. These are most of the areas in polygon. In polygon, right? In polygon, the most of the areas. Most of the areas. Okay. The next step, we have to do one thing. before going to next step, we have to select by location. In order to select by location, for example, you can collapse all this and avoid unnecessary data from your table of content. Especially, you can avoid all. Press Shift and avoid all this. Okay. Avoid all this. Remove this. Only we do have 9. 1, 2, 3, 4, 5, 8, 9 data set here. So the next step is select by location. Go to Data Management Toolbox and Data Management Toolbox here, and go to Layer and Table View. This one, Layers and Table Views, and select by location. Right? Bring this select by location into your model. Our input is the most opt. Our input is what? The most opt. This one. Intersection, right? Now we are going to play intersection relationship with road. Okay. Road. That means now we are going to select the best site. The best site means which is close to some infrastructure like electricity, road, water, and hospital, and on, right? So out of any optimal site, we are going to select the best site in terms of infrastructure. So in this case, in terms of road, intersect into road, and the selection type should be new selection. Okay. Selection type should be new selection, and make it okay. Right here you do have this. Okay. And then select layer by attribute. The next one is select layer by attribute. Select layer by attribute. Okay. Let's select layer by attribute. Drag this one again. Will be this one. Okay, selection type of the most of the area, and then here you can get shape area should be greater than or equal to, in this case, greater than or equal to 14,553. Okay, let's say 14,500 greater than or equal to this one, and okay, and apply. Okay, all right, and here, okay, again, add to display. Okay, and then finally, one more final step. Go to your ARC toolbox, copy feature tool. Open copy feature tool from data management, right? Data management toolset. Sorry, data management toolbox. Feature toolset. Features toolset. Data management. Features toolset. And copy features tool. This one. Okay. Copy features tool. Open it. And our input is what? The most optimal area. This one. Most optimal area. And browse to your folder. Here, the final site that you are going to propose for new school. Final school site. School site. Final school site. Okay. That's okay. final school site. And now auto layout, and then for extent, and then this one add to display, and then run your model. Yes, it is done. Now let's see that area. You see that area? It is selected there. You can save your model. You can save your model now. And go to your table of content. This is the final site. See, the final site is here. It is selected. It is selected. The final best site for school construction. You can deselect this one, and you can change the color of this one. Let's make it, this dark rose. Yes, this one is the final site selected for school. Now you can propose this site for school construction or development. Thank you for watching. Next time we will see another topic.